time is 10:30, at least then Danish time. So this is the announced time of this webinar. I see that there is still coming a few participants in, but I think we'll just start out slowly. Very welcome to all of you to this last webinar in the series of basic nutrition. The first two webinars was discussing the concept of energy in pig feed, and the second one, protein and amino acids. And this last webinar is addressing, well, basically the rest, additives, micronutrients in general, including trace minerals and vitamins, and as well as macrominerals. So I will try to keep the time. For those of you who participated at the previous webinar, you might remember that time got a little out of hand, so I will promise you that I'll try to keep the announced time frame. Today's webinar, as I said, is concerned or discussing all the remaining nutrients as well as additives that cannot be considered directly as nutrients, but which helps optimizing the nutrition or health and performance. So when we talk about minerals, the sources of minerals are, sorry, I just need to turn off my phone. Well, as long as we talk about the macrominerals, the main part is actually coming from the feed materials. But the problem is that, especially if we move on to trace minerals, and yeah, actually it also includes vitamins, the content can be very variable, and also caused by differences in soil properties, fertilizer use, and so on. Also, different types of feed materials have different levels. So also the composition of the diet influences the level that we have to supply from mineral sources. The most dominating, at least from a volume perspective, in the feed for pigs is calcium, typically from limestone. But of course, there's also some contribution from the phosphate sources. Phosphorus, of course, mainly from MCP, DCP. We have the sodium from salt or bicarbonate, chloride, magnesium, and potassium. Trace minerals, typically that we add and may control the level, is copper, zinc, manganese, iodine, and selenium. And as you see, there's different sources, which I will not discuss in detail in this presentation because that will simply take too much time. But I will try to walk you through the main sources, the main purposes of these, the main functions of these minerals in the feed. If you remember the discussion about energy and amino acids, we were talking about digestibility. This concept, the digestibility of concept, has not yet and maybe never will reach the mineral nutrition, because it's more a matter of regulation in the body. What we are slowly, and in some areas more than others, focusing on is the availability of the minerals in the source. So of course the total content of the source, the component used, but also the availability, which in a simple way could actually be explained by solubility. One of the other challenges that we work with when we talk about minerals is that if they are too soluble, so to speak, is that if we have a lot of ions, because when minerals dissociate or dissolves, they are usually enters an ion form, and unfortunately ions are quite reactive, meaning that they will always seek to react or bind to something else. So always it's a matter of a balance, trying to avoid that these ions start forming molecules or complexes that basically is not absorbable in the animal, because then these minerals are basically lost in a nutritional point of view. So that's also something we have to keep in mind. The macrominerals are, as I said earlier, mainly supplied from feed materials, or a fair part of the way. Some of them are to a wide extent added in mineral forms, mainly calcium, potassium, phosphorus, sometimes magnesium, but for pigs, rarely we add a potassium source. Common for these macrominerals are that they are absorbed mainly in the small intestine. Of course, there are some differences between the individual minerals. Again, it will be too much to get to that in this presentation. But this also means that they are, as they are mainly using the same pathways of absorption, balance is very essential, because if one mineral is supplied in excess volumes, they can actually block or reduce the absorption of the other minerals. So this is why it's very important to maintain a balance and not just extremely try to force, for example, a higher calcium content, a higher calcium absorption, because also what happens from the animal is that if the calcium content of the feed or the digester is very high, the animal, the regulation will basically just turn down the relative absorption, but this also harms the other ions in the same category. Some of these minerals can represent some toxicity. Calcium and phosphorus normally not. The electrolytes, sodium chloride and potassium, in theory, can be quite toxic. However, the pigs can cope quite well if they have sufficient water supply of a good quality available. Of course, also water free of these electrolytes. If the pig can drink enough water, they can simply excrete these electrolytes through the urine, why they are quite able to cope. In another situation, if water is not available or the water quality is poor, high mineral content and so on, actually the pigs can be fairly sensitive. Also for magnesium, high levels of magnesium can actually cause diarrhea, so it's not so severe, but it's still unwanted. The most important functions, as you see here, calcium and phosphorus, to some extent magnesium, is structural. It means the major part of those minerals in the body is located in the bone and teeth. But also these minerals have other functions in the body, nerve function, muscle contractions, blood coagulations, and as you see, some of them are involved in enzyme systems, either as coenzymes or activators, or directly built into the enzymes. Some of them, as calcium is strongly regulated, there's a very strong homeostasis, where, among others, vitamin D plays a significant role. You see, phosphorus is actually not regulated, but it's related to calcium. So the regulation in calcium also influences the phosphorus metabolism. Phosphorus is also a very important nutrient, as phosphorus is involved in the cell energy turnover, built into the cell membranes as phospholipids, and also has a role to play in the DNA RNA transcription. So as you see, a lot of different functions and a lot of things that can be influenced if they are supplied in too low levels. One thing that we see sometimes in Denmark is that farmers and veterinarians and maybe also some nutritionists seem to recommend sometimes increasing the phosphorus level in the feed. And well, to some extent, this can be justified. But I've seen a few cases where without increasing the calcium at the same time, so not maintaining more or less a calcium phosphorus ratio, you could actually end up in sows expressing something that looks like milk fever. And I hope you will be able to see this. There's not, if you cannot hear any sound, don't worry, because it's not really that important. But as you see here is a sow in a state of cramps, and this is actually what could happen if calcium phosphorus ratio is too low. The example, not this specific video, but an example is that sows would develop these cramps just shortly before farrowing, meaning that if the farmer did not inject calcium, this what is it called, calcium gluconate, borgluconate solution like used in dairy cows to prevent milk fever or treat milk fever, they would actually lose the sows and the pigs as well. But this was also a calcium phosphorus ratio where there was actually less total calcium in the diet than total phosphorus. Usually somewhere between a ratio of 1.5 to 2.0 is recommended. And in this case, it was less than 1. So keep this in mind. Sometimes phosphorus helps, but it can also cause challenges if you don't try to maintain a balance. Oh, sorry. So on macrominerals, I've shown here the Danish recommendations. Of course, the tables are much more extensive than I can show here. And this is why I've shown some intervals, and also the Danish recommendations is sort of developed based on the energy unit, feed unit. So the numbers you see here is sort of the equivalent, the conversion factor into grams per kilo. And also, as there are different recommendation sets, you see there is also some variation within for example, the calcium and the zinc oxide or zinc. You see that magnesium, for those who might have some knowledge of the Danish recommendation system, you might notice that the magnesium levels have been increased recently. Even though a lot of research actually states that 0.4 grams per kilo should be covering the demand, actually there is some new evidence indicating that especially for younger animals and animals with a high metabolic turnover, more could actually be needed. So this is why Segis this year, or was it last year, chose to increase the recommended level of magnesium in the diet, which means especially in pre-starters, you might need to supply some extra magnesium because it can be a problem to reach these levels just based on the natural content of magnesium in the feed materials, for the typical feed materials used in pre-starters. Normally, it will not be a problem for older pigs, but you should address this and keep it in mind. When we're talking about trace minerals, we are typically talking about iron, copper, manganese, zinc, iodine, and selenium. They are partly supplied by the feed materials. We only add or declare the added volumes because the content in the feed materials are quite variable. Even despite this, the legal limitations are actually based on total content. So we have to keep the natural content of the feed materials in mind, which is why we normally will not add as much as the law actually allows as total content. We need to keep a certain margin. Again, absorbed in the small intestine, like the macrominerals. Some are more strongly regulated than others, and also the macromineral or trace minerals are competing for its absorption. Why a balanced level is absolutely recommended. You cannot force, well, you can in theory force more of one specific mineral by increasing dramatically, this could cause other trace minerals to be absorbed on a lower level. There's a different toxicity risk. The most toxic trace mineral of at least of those, of course, there are other trace minerals that are not normally considered from a nutrition point of view, is selenium. You don't need to go very high in selenium before you start seeing a toxicity or intoxication in the animal. Others could be a bit higher. If we talk about the most important functions, iron, not surprising I think, is hemoglobin, transport of oxygen in the body. That's the overall main task of iron, but also involved in enzyme systems and involved in the immune system. Copper, important for the energy metabolism, bone growth, plays a role in the production or the synthesis of hemoglobin molecules, as well as enzymes, immune system, and so on. Manganese, enzymes, immune system, reproduction, and zinc is actually the trace mineral who influences the largest number of enzymes. Currently, more than 300 enzymes that is depending somehow on zinc has been identified. But as you see, also reproduction, immune system, and electrolyte balance regulation. Iodine is relatively specific. Main task is in the thyroid gland, producing the hormones, but also to some extent reproduction and immune system. And the main task for selenium is actually as a component in the natural antioxidant systems of the body, regulating the thyroid gland and as well as immune system support. If we talk about iron, I believe most of you might know of, or maybe actually supply injectable iron for neonatal piglets. And why are we actually doing this? Well, as you see here, pigs are born with roughly 50 milligrams of the iron in body, but only 5 is available for hemoglobin synthesis. If we look at sow milk, it's estimated that sow milk supplies around about 1 milligram of iron per day per pig. And we typically inject 200 milligrams as normally in the form of iron dextrane. And knowing that 67 milligrams of iron is required per kilo of gain, we can do a calculation that actually shows that even if we are injecting 200 milligrams, in theory, there is a deficit, or if we want a weaning weight of 6.8 kilos, there's a deficiency of 135 milligrams during the lactation per piglet. So a lot of attempts have been done to compensate for that. It's very difficult to influence the iron content of the milk, and it's at least at the best not efficient. So actually what we have started recommending is to administrate oral iron products at the end of the lactation period to avoid to wean anemic pigs. Some work has been done, and actually who estimates that as much as 70% of the pigs weaned could actually be anemic. Also, this is also related to the age of the sow. As you see, the sows themselves, as they grow older, they will have a decreased hemoglobin level, but also there is an effect of reproductive stage. Some work had been done also showing that there is a correlation between hemoglobin status of the piglets at weaning and the daily gain for the first weeks after weaning. This trial was not a sort of treatment trial targeting the hemoglobin level of the pigs, so we don't really know if it's something that influences hemoglobin that is responsible, or if it's the hemoglobin directly. But at least what we can do, as iron is not extremely expensive, we can at least try to increase the hemoglobin level of the pigs to make sure that that's not the reason. And also, many of you knows that copper has a growth promoting effect. It's been known for decades. It's a very cheap and effective way. Earlier, and I believe it's still done in the US, 250 ppm from copper sulfate will lead to a better daily gain and FCR. Years ago, 20 years ago, there was sort of a tendency in Denmark that still be using for pigs of 50 kilos, still be using a level of 50 ppm, even though for finishers in EU it's only allowed with 25 total, meaning that normally we cannot add more than 15. Copper probably works due to a direct antimicrobial effect, because even if we increase the copper in the feed, not a lot is actually absorbed. So another thing that could explain a better performance is also that copper influences the production of growth hormone and ghrelin, a substance in the stomach who's actually regulating appetite. I'll not be addressing zinc and zinc oxide because we have separate webinars for that, but also zinc, of course, has been known. Now it's in the EU in a few months, we cannot do that anymore. As to prevent post-weaning diarrhea or to control post-weaning diarrhea. This is probably more a matter of increasing the absorption either by very high levels, actually stimulating the passive absorption, because zinc, when it has an effect on post-weaning diarrhea, is more from it needs to be absorbed. It's not working directly antimicrobial in the gut. When we talk about levels of trace minerals, these are the Danish recommendations again. And as you see, copper is actually on a fairly low level, quite a low level, which could in theory be covered by the natural content of the feed. So we don't necessarily need, from a deficiency point of view, we don't need to add copper to the diet, but as we know that it has a health promoting effect, gut health promoting effect, we tend to do it anyway. And this is also why I've stated here that we will normally recommend to add the maximum legal level of copper in the diets. So you see here, and also you see for finishes, the Danish recommendation actually has a lower recommendation for zinc when using phytase. And this is explained by phytase limiting the complex forming of minerals in the gut, meaning when we are using phytase, we can actually get away with using a little less. And as again, the major part of the zinc is not absorbed, it's actually excreted. A lower level in the feed will actually lead to a lower deposition in the environment. So when we speak about vitamins, the history is not that old actually, but it's been known that there were some substances that was essential to maintain a normal healthy life. But it's actually only a little bit more than 100 years ago, the first one was discovered. And as you see, some of these vitamins are actually relatively young. But it's essential components, it's essential nutrients that are not building blocks like minerals and amino acids, but they're actually just facilitating biological systems. The vitamins are normally divided into water-soluble, mainly the B vitamins and the vitamin C, and the fat-soluble vitamins A, D, E, and K. Just to show you what happens if there's not enough vitamins in the body. Biotin is essential for keratin forming and so on. So you might see some poor claw health. Vitamin C deficiency, we don't see that often, but you will also see an increased risk of bleedings at the navel. Pantothenic acid, you will have splay-like. It's also sometimes associated with the deficiency in choline chloride. The most typical we see most often is actually a vitamin E deficiency, also called mulberry heart disease. And I'll get back to seasonal variations on that. One thing to say about the fat-soluble vitamins is that they cannot be absorbed unless there is a suitable level of fat source in the diet. So if we don't supply fat, well, you could risk harm the absorption of fat-soluble vitamins. And also here there's some competition where D and K seems to share the same absorption mechanism. Vitamin A is not affected by DEK, but the other way around, there is an influence. So again, a well-balanced formulation is essential. Also, the fat-soluble vitamins are actually stored in the body, which could lead to risk of intoxication, why we have legal restrictions on how much is actually allowed in the feed. The fat-soluble vitamins are responsible for immune reproductive functions, antioxidants A and E. Vitamin E can actually be transferred to the piglets through the placenta, but milk is still the most important source. Vitamin D is involved in the regulation of calcium and phosphorus, but indirectly on phosphorus, on the homeostasis and absorption. And there's also some new research indicating a relation between the level of vitamin D and microbiota diversity in the gut. Vitamin K is actually relatively specific as its main function is as a coagulation factor responsible for the ability of the blood to do coagulation. A few comments on vitamin D. Not many years ago, a new type of product form, a chemical form of vitamin D appeared in the market, 25-hydroxycholecalciferol, or the commercial name called High D. Basically what it does is when the normal vitamin D3 it needs to be absorbed and sent to the liver, where it is converted into 25-hydroxy D3, calcifediol, and led into the bloodstream. This is only partly regulated and it's not active. What happens is then when vitamin D is needed through the tissues, muscle or kidney typically, it's once again transferred into 1.25 dihydroxy D3, which is the active hormonal form, which is strongly regulated. So if we would try to supply this type of vitamin D, most likely it would be down-regulated from the absorption point of side, and then we will not actually achieve anything. We can actually make sure, however, that there's enough 25-hydroxy D3 in the bloodstream, so that we'll never get into a deficiency situation. And the Segis some years ago did a trial showing that using high D for sows would actually increase birth weight and weaning weight of the piglets, and also increase the number of pigs that the sows are able to foster. So based on this, there was a strong increase in by this type of vitamin D use in the Danish market. When we talk about vitamin E, there's a lot of older trials. I've chosen to show this one where we were involved. It's a few years ago as well, including 16 farms with approximately 14,000 sows in total. Some sows were allocated to a treatment saying, okay, we'll do a 1500 milligram per sow per day of what is sometimes referred to as natural vitamin E. It's a specific monomer of the aid that is present in vitamin E, or they would get 3000 milligrams of the normal standard vitamin E. Actually, what we saw was that both applications would reduce stillborn, but the best efficacy and profitability was actually with the normal standard vitamin E, even though the level was higher, but as the cost is significantly lower, it was actually more profitable. When we talk about antioxidants and vitamin E, and this is also associated to this mulberry heart disease, we traditionally focus on adding or increasing the vitamin E level in the diets just after harvest, typically 2 months, because when we harvest the grains, when we harvest the cereals, they are still biologically active, and in the silos there's a sort of after maturation producing free radicals and peroxides that can harm the pigs. So by increasing vitamin E, you can sort of counteract this. As soon as the cereals are finish this maturation, you can again reduce the vitamin E. And typically, we would go with plus 50 milligrams per kilo to counteract that. But we see that sometimes, especially fast-growing animals, young or fairly large piglets of 20 to 30 kilos that have a very high turnover, sometimes we see that if there are some sudden deaths, the veterinarians performs autopsies saying, okay, it's a pale, enlarged heart, mulberry heart disease. Well, then we need to go and supply extra vitamin E. The water-soluble vitamins, the B complex and the vitamin C is basically not stored in the body. Meaning we have to have maybe not a daily, but a steady supplementations. But on the other hand, this also means that the risk of intoxication is quite small. The common task for the B vitamins basically is metabolic turnover, to try to cut it really down to the essentials. Vitamin C is also really important in the immune system, but as pigs are, or maybe the microbiota of the pigs are to some extent able to produce vitamin C, and also the commercial forms of vitamin C are actually either relatively unstable or very expensive. Vitamin C is often only used in piglet diets or maybe sow lactation diets. Biotin, as I showed you earlier, has a very strong, important function in the claws, but it corresponds with zinc, copper, and manganese. So if there's a problem with the claw health, you should look into biotin. You should look into those 3 minerals. But my experience tells me that there's a sort of an optimal level. Again, if we go too high in biotin, we would actually end up performing or creating very hard claws that have a higher risk of cracking than if they were more flexible. So too much and too little can both be harmful. This old trial actually shows what happens if you increase the B vitamins for finishers. And of course, it is a fairly old trial, so this is why the levels are not as high as we see today. But it shows that increasing from NRC, which is the American recommendation, you see that by increasing the B supplementation, you also will see a higher performance. So again, talking about the recommended levels, you see these are the Danish levels. I know there will be others, and please remember these are minimum recommendations, especially the numbers marked by red. Typically, we will recommend our customers to go a little bit higher, as we have experienced and to some extent also trials documented that this increases performance. Especially vitamin K is often added in at 4 to 6 milligrams instead of 2, roughly, partly because vitamin K is also a relatively sensitive vitamin, so heat processing and so on can actually reduce the level. So that was macrominerals, trace minerals, vitamins, and now we are moving on to other additives. Acids has been used, discussed, mode of action, so on for years and years. We're constantly learning more. What we know is that acids can kill gram-negative bacteria, at least the short chain or the typical fatty acids. You see here the MIC values example that formic acid and benzoic acid is actually quite effective. Formic lactic combination is also quite good, but not necessarily better than formic alone. So what happens is that the dissociated acids will enter the bacterial body or the bacterial cell and then influence the pH. The bacterial cell will then respond by trying to pump out electrolytes to stabilize and maintain a certain pH inside the cell, eventually leading to the death of the cell. Feed preservation is also, but I think the reason why most people are using acids is because of that it reduces the digestive problems. Also, acidifying the diet and thereby acidifying or helps the animal acidifying the stomach leads to a better bacterial kill in the stomach, but also it leads to a better protein digestion. As you, especially young pigs, can be challenged when it comes to maintaining a low and from a protein digestion point of view, optimal pH in the stomach. Adding acids into the feed, controlling the buffering capacity, the acid level of the feed, will help the pigs compensate for that. Other additives, as you see here, there's a review. It's not that new, but it's a review of what has been done in Danish Pig Research Center, or what is today often referred to as the SAGES. And you see, actually, the additive that has the highest success rate is actually the acids. And you see some of the others are much less successful. So everybody today are using acids. It works. Liquid acids are cheaper, but there could be some disadvantages in the handling. It's more corrosive, it's more acidic, and can be a problem for the workers. There are some acids that are dry from the beginning, citric and benzoic acid, and on the other hand, also calcium sodium salts are used. Also adsorbates, whereas a carrier is used to spray acids, the liquid acids on, and also we see blends with essential oils, short chain fatty acid, medium chain fatty acids. Coating is used in an attempt to sort of control the release of acids, so that there will be some that also reaches the hindgut, unless if not, they are most likely to be metabolized within before they reach the hindgut. And we actually, I now see that I forgot to change this. We have introduced a Acidification concept, which is replacing the older Phytase and BF acid. So Acidification is our new concept. Fatty acids is basically the same, but sometimes we see them bound to monodeotriglycerides, and this could increase the survivability of the acid through the stomach, and also increase the MIC values and efficacy. But these products are fairly expensive. One of the interesting part is the C12, the lauric acid, as it seems to be able to inhibit the gram-positive bacteria and some viruses. When we talk about additives, also enzymes is a very important part, and by now I think it's in most parts of the world well established the use of phytase to increase the utilization of phosphorus. Phosphorus is a limited resource. Recently, it has become extremely expensive, so we need to release the phosphorus hidden in the feed materials, especially cereals. Phosphorus are bound in the phytate molecules, and the pigs cannot produce enzymes that can sort of start the process of releasing, because phytate contains typically 6 phosphorus units, and we need to get this process going. So to initiate this, we need to add phytase. Once we reach a certain level, typically we start by the one called IP6, and the phytases will degrade to IP5, IP4. Once we reach IP3, actually the enzymes of the pig itself can take over and do the remaining. But it's also a matter of time, so the more phytase we add, the faster this is, and we should make sure that as much phosphorus is released as possible before we reach the end of the small intestine, because that's where we sort of can absorb or count on an absorption. So phytase is essential. Denmark today is using very high levels. As you see here, we have a system of a relative dose, meaning that we can sort of range different products against each other. The example here is based on the Vilofoss units. So if we say 100%, this equals 500 units of Vilofoss. And you see we have different levels depending on the component, but you also see that the mineral sources of phosphorus are not influenced by the use of phytase. They have the same because there's no phytate in the mineral sources. Which level is the most optimal one is depending on the cost of the mineral phosphorus sources. And again, right now the prices are very high, so actually the economic optimum is to go 3 to 4 times the standard or dose. New generations of phytase might be able to go higher, but as you see in this diagram, when we are at the highest level, there's really not a lot more to go for. But we can hope that we can get even further with new generations. Economy, yeah, this is an example. You should do this analysis saying, okay, based on this for different types of feed, this is sort of an optimum at 200, where 300 is not necessarily worse. So to reduce sensitivity of phosphate prices, 300 should be done today. Maybe even 400 is actually the optimal. Other enzymes in the category of non-starch polysaccharide helps degrade carbohydrate structures that monogastrics cannot normally digest. You could also argue that they are called fiber. Typically trials show that we can count for a 1 to 3% increase in energy utilization in pigs. There might also be some release of protein or amino acids that are caught in fiber structures, but it's difficult to evaluate. You might see some of the products actually working with a matrix on amino acids as well as energy. Recently a new type of NSP entered the market, which is not targeting actually. The main target is not to increase energy; it's actually to reduce some specific carbohydrate types that is anti-nutritional for the pigs, cause inflammation. So this is another way to reduce or improve the feed efficiency of some pigs. So when we move on to aroma or flavor, which is actually two different things, even though it's often talked, people often talked about it as the same. It's mostly used in piglet feed. Flavor might actually be the one that works. If you think about the table of the Sage's Danish trials, it was actually 8 to 14% of the trials who had a successful outcome. Aroma is more what you smell. It's a little bit more discussed. You could serve maybe as an attractant, making sure the pigs are interested. But sometimes my impression is that it's maybe more the benefit of the farm manager or the farm worker that this smells nice and I want to feed it to my pigs. There's some work on lactating sows during heat stress conditions, adding a sort of a compound that is characterized as an aroma or flavor could actually increase feed intake. And there are some potential of maybe influencing the pigs to have some preferences through feeding the sow and making sure that there are some molecules transferred through the milk. And there are also some of these molecules it has actually been shown to increase appetite. Phytogenics is a very, very broad range of plant extracts. I can't even put a number on it. There's a lot of bioactive molecules identified from all different types of plants. Some companies might have some insight, which they are not interested in sort of telling in detail, because they, of course, that's proprietary knowledge. From our point of view, we are still a little bit in the dark on what works, and what our experience is that we normally need to apply relatively high levels to see an effect, which is normally not profitable. It's very probable that there will be some synergistic effects in combining different phytogenic substances. Normally, they are thought to know as anti-inflammatory, antioxidants, antibacterial, stabilizing the gut wall, destabilizing bacterial cells, also called acid boosters. Typically, they are supplied in combination with an acid. But I think a lot more testing and development is needed before we can really benefit from these products. And then the whole group of probiotics. Well, this group is developed into prebiotics, syn, post-proteobiotics, which is basically all related or situated around microorganisms that supply to the feed, able to live in the host animal. Legally, they're not allowed to colonize the animal so that they can sustain themselves or in the environment. Prebiotics are more specific carbohydrates that sort of specifically feed some selected microorganisms. It's quite poorly defined. Symbiotic is basically a combination of the two first ones. So you could say, okay, we have a bacteria, we provide a substrate so that we know that this bacteria will produce some substances and metabolites, which are the proteobiotics. And postbiotics is also, well, basically dead microorganisms. Again, a lot more work is to be done on this. The best known is probiotics, but still, yeah, the classical approach to probiotics is actually a sort of we provide microorganisms to make sure that others don't grow too much. But I think there's a lot more to it, so I'm looking forward to learning more about that in the future. Also, we see some companies promoting nucleic acid or nucleotides, which is basically building blocks of DNA and RNA, similar to how amino acids are building blocks of protein. The theory is that fast-growing animals might be deficient, and why a supplementation could sort of compensate for that and improve performance. It's relatively common in aquaculture, but I see there's a poor documentation when it comes to pigs. Toxin binders are not really an additive, but I chose to include it here as well. Anyway, because it's widely used, often as an insurance. You never know when toxins, mycotoxins could appear. There's a different components or mode of actions. You'll have bentonite binding, bentonite, algae, and yeasts, enzymatic modification, and also some phytogenic substances that typically support the liver, including B vitamins as well. Some institutions don't really believe a lot in it, but we see over the years a strong increase in the demand. So there's a market, and it's also relevant as an insurance. We see some new products in the market focusing on endotoxins, which is, you could say, leftovers from dead bacteria that can have a toxic effect on the pigs as well. So this might be another further reason to add something in products like this. And finally, we also see algae-based products. Until now, complete algae products have not been yet convincing. We have tested out a few of them, but there is a few bioactive molecules that are promising, mainly laminarine and maybe also fucoidan. But still a lot more work to be done, a lot more to be learned. But the good thing is, with all these products that we need to learn more about, is that everything is not yet explored, and there's a possibility of further improvement in productivity. So, thank you. Any questions? You're welcome to ask them now. And please, if you are interested, our next webinar in a couple of weeks will be on staloson used for poultry. So please sign up for that one if you're interested.
Yes, thank you, Jacob. We have one question until now. What about iron absorption by the piglet in lactation phase and weaning?
Yeah, let me just get back to the iron. Yeah, you see that I cannot say exactly how much. As you see here that milk production or milk during lactation is actually calculated just to supply 30 milligrams per piglet throughout the lactation phase. We assume that there's a high availability, high absorption of this. But we don't know the exact absorption rate. But still, it is very low compared to what the pig actually need. You could see if we calculate 5.5 kilo gain per piglet, it requires actually 370 milligrams of iron, and only 30 at the best will be available from the milk. Again, injection is important. Some have had some experience with applying iron to the drinking water of the piglets. But as piglets, especially young piglets, don't drink that much water, they mainly drink milk. I think this is a method to supplement and not to assure an optimal supply of iron. The drinking iron could supply could be a supplement to avoid deficiencies at weaning, but you could maybe do that also by extra iron in if you apply milk or simply a dry product to allow the pigs to eat.
Yes. One second question. Isn't there a risk of too low milk production if you limit calcium level in lactation diets?
You could argue that, and I know that at least earlier sorry, I just needed to find this table. So earlier, at least earlier, the Dutch recommendations were closer to 10 grams, and as you see here, the Danish recommendations are somewhat in the area of 8 grams per kilo. But the thing is, the homeostasis, the regulation of calcium in the body of the lactating sow is really strong. So even if the feed is deficient, the sow is able to mobilize an extreme amount of calcium from the bones. Of course, this should not be sort of an actual strategy, because in theory you could develop osteochondrosis and poor bone strength doing that. But in general, I wouldn't be afraid if we keep these levels of 7 to 8 grams per kilo. I wouldn't be afraid that we will deplete the bones, and I'm sure the sow would provide enough milk. It's not calcium who's limiting the milk production. Yes, it seems that there are no more questions.
Sorry, sorry, just Jacob, I forgot to unmute my.
All right.
Would you expect improvements when using an organic iron source, chelate? Is that available?
It is available, and let me just. Yeah, it is available, and there's some evidence that you have a higher level of iron status in the body of the pigs. I've done a trial myself trying to measure hemoglobin, where we were not really successful using a chelated product, but there is some research showing that using chelated or organic iron sources, we could actually in theory improve performance, but I think there's more to it, so we need maybe to combine with other nutrients to have the maximum output. And another thing is, as always, using a product that is significantly more expensive than the inorganic sources, of course you should always look into the economic perspective of using it. On the maybe you should look at the full life performance of the pigs, because it can be difficult to find the profit just by looking at until weaning or through the nursery. But I think there is an option, a possibility. I'm a little bit more concerned about the actual profitability in using organic sources.
Yes. The next question is, if in the lactating room is very hot, more than 27 degrees, what is more important? Add vitamin C and what else? Also for the sow.
Yeah, I would actually go for increasing, of course, depending on the level that is already in the feed. But I would go for increasing maybe the vitamin E and the C, because there's an interaction between vitamin C and E. Vitamin C can actually, besides being an antioxidant itself, it can also regenerate vitamin E as antioxidants. So you get a better utilization of the vitamin E when you use vitamin C at the same time. But maybe the most important thing, vitamins wise, is actually to include betaine in the diet, because betaine, as the main problem if you have heat stress, is actually a change in the osmotic pressure in the cells, and betaine helps control that. Zinc could also help, but it's not always possible to increase the zinc levels of legal reasons. So I would definitely go for betaine and supplement it with vitamin C, but you could also maybe have some benefit from manipulating the electrolytes a little bit as well.
Okay. You mentioned zinc oxide doesn't have a direct effect on bacterial growth in the lumen. There are studies showing the opposite, a negative correlation between E. coli and zinc oxide. How to justify these results then?
If I understand correctly, there is some research indicating that you could actually promote E. coli growth by using high levels of zinc oxide, I know that there are some studies maybe not showing directly an increase in E. coli in general, but maybe promoting E. coli containing antibiotic resistance genes. And there was some work done by the University of Berlin, as far as I remember. And this is one of the reasons why we have the ban of medicinal zinc oxide coming up very soon. The main physiological function of zinc when using very high levels of zinc oxide is actually limiting the loss of electrolytes in the gut, and as well as strengthening the tight junctions between the epithelial cells to avoid entrance of unwanted substances in the bloodstreams as well.
Yes, one last question. How do you think about special sources of zinc oxide to counter the new legislation of low zinc?
I assume the question is more looking into micronized and coated zinc sources or zinc oxide products. Personally, my experience using this kind of products have not been very positive. At least they might be able to improve performance slightly, but within the normal EU legal levels of zinc, the efficacy will not get in anywhere near the effect when we are using the very high levels of 2,500 ppm. So using 110 ppm, we could have a slight improvement by using special sources, but it cannot compensate for not using the 2,500 ppm.
Okay. Thank you, Jacob. No questions more. And yeah, thank you for a really good series of nutrition basics for pigs.
Thank you for listening. And as always, should any further questions appear, please direct them, send us an email, and we'll answer you directly.